So 8 said, find the standard form of the equation of a parabola with the given characteristics. So we've got a vertex, which is going to be my HK, and then a focus, which is 5, 9. Sorry, yeah, HK, which is 8, 9. So if you graph it, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's my vertex. And then 5, 9. 1, 2, 3, 4, 5, 9 is my focus. So from there, I know it's going to go left, right? If it points left, it's a y squared, but it's a negative 4p. And then I need the p value, so I'm going from 5 to 8, which means p is 3. So I'd get y minus the k, which is 9, squared equals negative 4 times 3 times x minus the h, which is 8. And then I get y minus 9 squared equals negative 12x minus 8. So you just switched which was squared, yeah. 7, this was the first one, so this is Tomas's. It says, find the standard form of the equation, and a lot of you missed this. It says vertex at the origin, so make sure you read carefully. The fact that it has the vertex at the origin means I'm starting at 0, 0, and then it's passing through 2, 1, 2, negative 1 12th. So because it's below the x-axis, so I know I'm going to point this down, which means it's an x squared and a negative 4p. Because it's 0, 0, it's like it's x squared equals negative 4p y. And then I would plug this in as my x and my y. So I'd get 2 squared equals negative 4 times negative 1 12th. Nope, let me put it in the right order. You're welcome. See you tomorrow, Sophia. Negative 1 12th. And then this becomes 4 equals 4 goes into 1 12th. 3 times positive, negative, and a negative makes it a positive 1/3 p. Multiply both sides by 3. So p's 12. So then when I plug it back in, my x squared obviously comes first. Negative 4 times 12 times y. So I get x squared equals negative 48y.
Wait, because I did it somewhere right here. I just realized it said vertical axis, so I did a y squared.
Okay. This is the second one. So same kind of question. It's still at 0, 0. 4, 1, 2, 3, 4, negative 1/8. So I know it points down. It's x squared with a negative 4p. The x in this case was 4. Negative 4, negative 1/8 times p. So this becomes 1/2, 16, 1/2 p. Multiply both sides by 2. So I get 32 equals p. And then you got to plug it back in and multiply by the negative 4. Did you just forget to multiply by the 4? Like you have the 32. I bet you just forgot to multiply it times the 4. That's the p. You just got to multiply by 4. Yeah. And then 11 said, find the standard form given the vertex of negative 6, 1. 1, 2, 3, 4, 5, 6, 1. And a directrix, so this is vertex, of x equals 3. 1, 2, 3. So I know it's pointing left because it points away from the directrix. Left means y squared, negative 4p. The vertex would be the vertex is there, sorry. The p value would be from negative 6 to positive 3, so p is 9. So I get y minus the k, which is 1, squared equals negative 4 times 9 times x minus a negative 6 becomes plus 6. Y minus 1 squared equals negative 36 x plus 6. You just literally didn't, you put the 1 twice? Yeah. Any other questions from the homework? All right, so far, and that's what the first 2 parts that are going to get covered on your quiz was the equation, taking the equation of a parabola and graphing it, finding the focus, the vertex, the directrix. Then, given that kind of information, find the equation, and we're going to kind of do the same thing with ellipses. We start with ellipses, and we're going to start with just the graphing part of it.
How many questions did you do?
1, 2, 3, 4, 5, 6. Yeah, because the graphing ones have multiple parts to it. Yeah. So 2 graphing ellipses, 2 graphing parabolas, 2 equation parabolas. Yeah.
When is our test?
Your test is next week, right? Next Friday? Yeah. Our testing days in semester 2 are Wednesday, Friday. Sometimes they approve a Thursday for math because Wednesday and Fridays are so many half days. Sometimes they approve a Thursday. If they do and we need it, we'll use that. But right now it's Wednesday, Thursday. All right, so ellipses. Ellipses are those ovals, okay? So we're going to do the same thing. We're going to start with, here's my equation, learn how to graph it, and then we'll flip-flop it tomorrow. But the quiz will end with what is on today's, like today's where the quiz content will end. An ellipse is the set of all points in a plane. The sum of whose distance from two distinct points, which are called the foci, is constant. So these are ovals. There's two different kinds. There's a horizontal oval and the vertical oval, okay? Horizontal means it's wider than it is tall. Vertical means it's taller than it is wide. There's a bunch of little parts to these. So you're going to learn a lot of vocab today. Okay, first of all, the ellipse in general. That's obviously something that's new. The center of my ellipse is the direct center of my oval, okay? From there, I've got two starting points, which are the vertices, which is the plural of a vertex, okay? Those lie on the major axis. The major axis is the longer one. So if it's a horizontal ellipse, the major axis is the x-axis, or if it shifts up or down, the horizontal axis, okay? So we go right and left, the vertex. On a horizontal one, we go up and down what's called the co vertex. So the co vertex is the end of the shorter axis. And then you've got a focus, and there's multiple of them. That's called a foci. When there's more than one focus, it's called a foci. And those are also on your major axis. So two things lie on the longest one, the foci and the vertex. And then on the shorter one is the co-vertex. If it's a vertical ellipse, then we still have the center, and we'd go up and down the vertex, because that's the major axis. We'd go right and left, the co-vertex, that's the minor axis, and the focus, again, is on the major axis, so we'd go up and down. So you see on these an A, a B, and a C. A is the distance, right? I don't have this on the slide next, do I? No. A equals the distance from the center to the vertex. If it's a horizontal ellipse, we go right and left that distance. You're going to want to write these down. So if you didn't already write that A one down, write it down. A is the distance from the center to the vertex. B is the distance from the center to the co-vertex. So if it's horizontal, we go up and down that distance. If it's vertical, we go right and left that distance. And C is the distance from the center to the focus. So the vertices should be the furthest out because that's going to be the longest measurement. A is the biggest of these three measurements. B would be on the shorter axis, so that's called the minor axis. Major is longest, minor is shortest. And then the focus is going to be along the major axis, but inside the oval. So whereas in a parabola, it's on the outside and the scoop goes around it, on an ellipse, the focus is on the inside of it. The equations, if the center is at 0, 0, look like this. X squared over a squared plus y squared over b squared equals 1. Or y squared over a squared plus x squared over b squared equals 1. Now, the order of the numerators is not important. X could come first or y could come first. The biggest thing that you want to pay attention to with an ellipse is the A is the biggest number. So if the A is under the X, that means we make the X longer, which means it's horizontal. If the A is under the Y, it means we make the vertical longer because we go up and down the A. So in this case, A is underneath the X, which is why this is horizontal. And in this case, the A is under the Y, which is why it's vertical. Again, that order can be completely switched. It could say y squared over b squared plus x squared over a squared equals 1. It's still horizontal. So again, if it's horizontal, I'm going to take the A and go right and left with it, and take the B, go up and down with it, take the C, go right and left with it. If it's vertical, I take the A, I go up and down from it, take the focus, which would also be up and down, and then the B would go right and left. The length of the major axis is twice the length of A, so it's 2A. And the length of the minor axis is twice the length of B, so it's 2B. You will see those more in the flip-flop of today's lesson, like when we finish it tomorrow, where I give you information and then you give me the equation. It doesn't very often ask you the length of the major or the minor when you're graphing. So to me, this feels really confusing when it's all in words, and I promise you the graphing part of this is, I didn't talk about it. This is super important. C squared equals A squared plus B squared. So you will always be given at least 2 of those, or a way to find 2 of those, and then you're going to use that equation to find the third. It looks like the Pythagorean theorem. The sign is different, okay? Super easy. The very first thing you have to do is look at this and say it is not equal to 1. So step 1 is make sure it's equal to 1. What do I do to get it equal to 1? Not subtract. Divide. Good. So I divide everything by whatever's on the other side of the equal sign, which in this case is 64. So 64 goes into 64 16 times. I get x squared over 16 plus y squared over 64 equals 1. So step 1 is get it equal to 1. Step 2 is figure out where's A. And how do we know which one is A? The bigger one. So what's A? Really, that's A squared. A squared is 64. So because the bigger number is under the Y, what kind of ellipse is this? Vertical. Good. So it's going to be taller than it is wide. What's the B squared? 16. I need to know A and B. So the next thing I'm going to do here is square root these. A is 8. B is 4. Yep. The original, if you go back to the equation on that last slide, it says x squared over a squared. Yeah, so the original one is squared. Now, if you want to pull in a coordinate grid, you can, but you can also just like loose hand draw these. I'm going to pull in a coordinate grid just so we see it, like what it looks like if it's exact. My center is 0, 0, 1. We haven't learned anything to do beyond that. But 2, there's nothing added or subtracted to the y. That's how, x or the y. That's how you would know it's 0, 0. So I have a point at 0, 0. And we said this is a vertical ellipse. So I count up and down the bigger term, which is the A. I go up to 8 and down to 8. And I go right and left the B. So I go right 4 and left 4. And then I close in the ellipse. Yep. The bigger, whatever the bigger term is under, like whatever letter that is, that's the axis that you're going to put it on. So because it's under the Y, it's vertical. So now your quiz is not only going to ask you to graph it, but it's going to ask you to give like the exact coordinate points. It's going to ask you for the vertices. The vertices are up and down, right? So this would be 0, 8 and 0, negative 8. The co vertices, we went right and left. So this is negative 4, 0 and 4, 0. I need to find foci, and that's my c. C squared equals a squared minus b squared. So c squared would equal, my a squared is 64, my b squared is 16. So 64 minus 16, and I get 48. That's c squared. To find c, I have to square root 48. To graph it, I'm going to approximate from here. So it's not a perfect square, right? But it's just smaller than square root 49, which means it's just smaller than 7. So we're going to say this is like a 6.9, which is going to help us graph it. But to actually give the coordinates, we have to keep it exact. So I break down 48 in my number or my factor tree. 2 and 24, 2 and 12, 2 and 6, 2 and 3. And it's 4 square root 3. Now, do I go up and down with the focus or right and left? Up and down, because that's the major axis. So on my graph, I'm going to go up and down 6.9. So I'm going to estimate it because it doesn't have to be perfect. And that's your focus, or your foci, because there's 2 of them. To give the answer as coordinate points, it is 0, and it is, I can either do plus and minus, or I can do 4 root 3 and 0, negative 4 root 3. So you could also write that as plus and minus 4 root 3. Bless you. Oh, bless you. The first one's always the roughest. I promise it will get better. Questions so far? Anybody? So this time it's already equal to 1, right? I eliminate that step. Which one is a squared? 9. And what letter is it under? Which means it's horizontal. So a is 3 because it's the square root of 9. B squared is 5. So b is the square root of 5. My center is still at 0, 0 because we, 1, haven't learned how to do anything other than that. 2, there's nothing adding or subtracting from the x or the y. So I start there. We said it's horizontal, so we go right and left the A. So I go right 3 and left 3. Those would be my vertices. Negative 3, 0, and 3, 0. My B is square root of 5, so we're going to totally approximate it as just bigger than square root 4, right? So just past 2 when we graph it. But when we write it, we're going to keep it exact, which would be 0, negative root 5, and 0, positive root 5. I can already draw my ellipse. Last thing I have to find is the foci. So I have my A and my B. C squared equals A squared minus B squared. C squared would equal 9 minus 5. C squared would equal 4. C would equal the square root of 4, which is 2. So I go again on the horizontal because that's my major axis. Right 2, left 2. And my foci would be negative 2, 0, and 2, 0. All right, so what happens when we shift off of 0, 0? The first thing is you should notice it because it will be attached to the x or the y inside the parentheses with the squared on the outside. So that tells you I'm no longer at 0, 0. It's just like a parabola where the x gets the h and the y gets the k. And just like a parabola, we would change the signs on it when we take it out. So if it said x plus 2 squared, whatever, over whatever, and then y minus 1 squared, my center is going to be negative 2, 1. So we change the sign of what's after the x, we change the sign of what's after the y, and that's our center. Everything else is still the same. The difference is it doesn't always look symmetric on my circle, on my grid. I still go right and left the A if it's vertical, and up, if it's horizontal, and right and left the A if it's horizontal, and up and down the B. And then if it's vertical, I go up and down the A and right and left the B. Everything else is the same. C squared still equals A squared minus B squared. I still find the foci the same way. The difference is where you start that point at. That's it. Everything else is exactly the same. Same set of instructions. Graph, find the vertices, co-vertices, and foci. It's already equal to 1, so that step is done. Where's my A squared? Under the y squared. So A squared is 16, which makes A 4. And it's under the y, so this is vertical. B squared is 9, so B is 3. And what's your center? 2, negative 1. Good. So start with your center. I go to the right 2, down 1. That's the center. My A is 4. Are we going up and down with that or right and left? Up and down. Good. So I'm going up 4. 1, 2, 3, 4. Down 1, 2, 3, 4. If you want to do those coordinates right now, feel free. Now it's 2, 3, and 2, negative 5. So if you compare it to your center, you went up and down, which means it's going to affect the y. We added and subtracted 4 to the y coordinate of my center. My B is 3, so I go 1, 2, 3 to the right, 1, 2, 3 to the left, and those are the co-vertices. 5, negative 1, and negative 1, negative 1. This time we took the h and added and subtracted 3 to it. That's how we got to that point. And then draw yourself your ellipse. And the last thing we need is our foci. So c squared equals a squared, which is 16, minus b squared, which is 9. C squared equals 7. C would equal the square root of 7. Not a perfect square, right? But it's in between what two perfect squares? 3 and 4, right? It would be in between... Yeah, 2, sorry. It would be in between 4 and 9. So it's in between 2 and 3. So we're going to approximate it because there's no way you're going to get much closer than that. Like, I'm not going to know the difference between your 2.5 and your 2.6 on a graph. Just approximate it. But here's the catch. I'm not going straight to 2.3, right? I'm going 2.3 away from my center. So I go to where the center is, and I go 1, 2, or 2.5 is what I said, right? Up, 2.5, 1, 2, down, 2.5. And there's my foci. When I list them as coordinate grid, as a coordinate point, you keep them exact. So because I'm changing the y here, my x would stay as 2, and my y, negative 1, gets the plus and minus square root 7. So So you can separate that out. It can be 2, -1 minus square root 7 and 2, -1 plus square root 7, or you can write it as plus or minus. This homework is actually a PDF, so you can write it as the plus or minus. You don't have to worry about the format. And the quiz, I would take either.
Wait, which one the -1?
Yeah, so you're going from the x, from the y coordinate of your, right? You're going up and down. So the x didn't change from my center. The x stayed 2. But then the y, which was -2, is what you add and subtract the root 7 from. Questions on that one? All right, so the first thing you got to do is divide by 16 because it's not equal to 1. So divide by 16 by 16. And then this one's already divided by 4. So it's easier to multiply this by 1/16. That's the same thing. So then I get x plus 3 squared over 64 plus y minus 3 squared over 16 equals 1. All right, so this is why you can't determine, like I can't use the initial equation to figure out if it's vertical or horizontal because that just changed, right? Sometimes the signs could change, like that kind of stuff. You want to make sure you wait to determine until after you've divided by what's on the other side. So now what's a? Or a squared? 64, which tells me a is 8, and it also tells me what kind is this? Horizontal, good, because it's under the x. The b squared is 16, so the b is 4. So and my center, the opposite of what follows x, so -3, the opposite of what follows y, so +3. So I'm going to go left 3 and up 3, and we'll put my center. And then because my a is 8 and it's horizontal, I'm going to go right and left 8. 1, 2, 3, 4, 5, 6, 7, 8. And left 1, 2, 3, 4, 5, 6, 7, 8. My b is 4, so I'm going to go up 1, 2, 3, 4, and I'm going to go down 1, 2, 3, 4, and then I'm going to draw my ellipse. Those vertices, so the first ones that I drew, I went right and left. The 8, so that changes my x value. I'm at +5 and +3, and at -11 and +3. Compare this to your center, and you went right and left, so you're adding and subtracting 8 from that -3. So those two things should line up. If I add 8 to -3, I get 5. If I subtract 8 from -3, I get -11, which is what I got from my graph. The co vertices were the up and down 4. So this is -3, 7, and -3, -1. Co vertices, I'm now changing my y by adding and subtracting 4. So 3 plus 4 is the 7 that I got, and 3 minus 4 is the -1 that I got. So also lines up with what I got. Then I got to find the foci. So c squared equals a squared, which is 64, minus b squared, which is 16. C squared is 48. C equals the square root of 48. So we know to approximate that to 7 or 6.9, just before 7. So I go right and left just less than 7 here and here, and those are the foci. And when I write those out, I'm adding and subtracting it from the x. So the x is the -3. -3 plus and minus the square root of 48, which became, we already did this one, 4 square root 3. And the y stays the same as my center, which is 3. Again, you can keep it as plus and minus, or you can separate it out. Doesn't matter. Raise your hand if you got it right. Good. Questions?
So whenever you're doing the foci, the -3, for example, there, it's going to be always your x-axis?
If it's horizontal. So whatever the major axis is, that's what you're changing. If it's horizontal, I'm changing the x. If it's vertical, I'm changing the y. Whatever you did to get the vertices, you do the same to get the foci. Yep. Questions on graphing ellipses? All right, so we're going to stop there. This is what your homework is. Your homework is a PDF, so make sure you're drawing those graphs. If you want to bring in the coordinate grid, feel free. If not, make sure you're drawing very, very accurately, but you have to have hand-drawn graphs for these, okay? And then tomorrow we'll do the flip-flop of this. Where we are right now is where the content ends for your quiz. So it's the parabolas, the graphing the parabolas, and then the finding the equation of the parabolas, and then the graphing of the ellipses.